Let's talk about the filter operation on RDDs and how you can use that to strip out information that you don't need from an RDD and save Spark from doing unnecessary processing. We're going to apply this to a real example using some real weather data. And the thing we're going to try to do is take a bunch of weather data from Europe and find the minimum temperature for a given location for an entire year, the year 1800 to be precise. So let's talk about how that works. Now, filter functions are pretty straightforward. You just pass in a function that returns a Boolean value, and that Boolean true or false value dictates whether or not a given row in an RDD gets retained or not. If it fails that condition, then that entry is discarded from the RDD. So let's say that our weather data has different kinds of information in it, and there's a field that indicates what kind of data a given line of input represents. It might have a minimum temperature for the day, it might have a maximum temperature for the day, and it might have a precipitation amount for the day. Now, all we're interested in finding in this example is the minimum temperature overall for an entire year for a given place, so we don't care about the maximum temperature lines, we don't care about the precipitation lines, we can throw those away. And this filter operation here is a way to do that. So let's imagine that we have an RDD that already has parsed out information about what's in this weather data. We could call a filter function that takes a given input line, checks whether the second field of it is equal to tmin, in the case that the second field is what indicates the data type. If it is, it keeps it. If not, it just gets discarded. And the resulting RDD that only contains tmin lines then gets put into the new min_temps RDD that we've created. So again, you use the filter function on an RDD to provide a Boolean function that dictates whether or not a given entry in an RDD gets retained or not. Let's make it real, look at some actual data. So we do have some actual real weather data from the year 1800 for a couple of locations. And this is the format that we have. The first is a weather station identifier, followed by a date, what kind of data this line represents, and the associated data with it. So for example, this weather identifier, I forget if it represents Paris or Prague, it's one of them, but it says that at this weather station, on January 1st, 1800, the maximum temperature was negative 7.5 degrees Celsius. Okay, so the data format here is a little bit strange. It's actually tenths of a degree Celsius. And also, for that same place on that same date, the minimum temperature was negative 14.8 degrees Celsius. And likewise, we have a precipitation line that we don't care about, because all we care about are minimum temperature lines. We have a maximum temperature for another weather station and a minimum temperature for another station all on that same day. Now in this example, again, we only care about minimum temperatures for the problem we're trying to solve, so we're going to take in all these lines of input data, we're going to parse them out, and then we're going to throw away everything that's not a tmin entry. So how does that work? Well, let's start by reading in the raw data and parsing it, making it more structured. So what we're going to do is take our Spark context and call a text file to import our comma-separated value list for the year 1800's weather data. And then we're going to apply this parse line function as a mapper on that raw data. So what does parse lines do? It splits it up into individual fields based on comma characters and parses it out. So the first field is the station ID. Field 2, which is actually the third field, is going to be the entry type. So that's going to be tmin, tmax, or precip. And then for the temperature, we'll extract that from the fourth field, field number 3, convert it to a floating point numerical value. Remember, that's tenths of a degree Celsius, so to convert it back to Celsius, we multiply times 0.1, and then to convert from Celsius to Fahrenheit, we'll multiply by 9/5 and add 32. So this reads in the temperature value and converts it to Fahrenheit for us. All right, so at this point, we're going to return a tuple that contains 3 values, the station ID, what kind of entry it is, and the temperature. So the next thing we want to do is discard all of the data that's not a minimum temperature. So to find the overall minimum temperature for a location throughout the entire year, we're going to look at the minimum of all the minimum temperatures reported for that location. So what we're going to do with this filter operation, like we looked at before, look at every input line, and if that second field, which indicates the data type, is equal to tmin, we'll keep it. Otherwise, we'll throw it away. So at this point, we have a new RDD called min_temps that contains parsed information, but only tmin data types. Now, we have an RDD that contains 3 things. We have the station identifier, tmin, and a temperature. That tmin is no longer meaningful, right? Because everything in the RDD has a tmin in it. So let's just get rid of it. Again, the less data that we have to deal with, the better. So that's what this next line does. We'll take that min_temps RDD we have now, apply this mapping function to it that takes that tuple of 3 data points and converts it to a tuple of 2 data points. And you know what a tuple of 2 data points is? A key value RDD. So at this point, station temps is a key value RDD, where the key is the station identifier, which is just the location, Paris or Prague, whatever it is, and the value is the temperature, the minimum temperature seen for that day. Finally, we'll do a reduce by key operation. And so this is a little bit different than where we added things up or made averages. Instead, we're going to use the min operator to preserve the minimum value seen as we go through all of the minimum temperatures seen for a given station ID. So station temps, to remind you, is a list for every day in our data set for a given station ID and the minimum temperature. So we're going to aggregate everything together by station ID, that key value, and we're going to look at the minimum min temperature seen across all the minimum temperatures reported for that station throughout the year. So that's what this reduce function does. For 2 given tmin values for a given location, for a given key, it will preserve the minimum of those 2. And by doing this, it will find the minimum overall temperature reported for that station for the year. Finally, we just need to collect the results and print them out. So we will call collect to transform our RDD back into a Scala object that we can iterate through, which we do here after sorting it. And there are more compact ways of doing this here. I'm doing this in 3 different lines just for clarity, but we'll extract the first key value and assign that to the station ID. The temperature will be in the second one. And then we will format that temperature so that it only has 2 decimal places to the right. And print out the final results for each station that we run into and take a look what we have. So let's go and run it in the next lecture and see what we come up with.